All right, the last section for this chapter is going to be 2.7, which is systems of quadratic equations. So this is going to be similar to the last time that we did systems. We're going to keep in mind using dashed lines, solid lines, and the shading as well. At this time, we're also going to include some quadratic equations. So the first thing I want you to do is to graph this quadratic, x squared minus 4x plus 3. And so to find that, because this is in standard form, I'm going to have to find the vertex first. And to find the vertex, hopefully you remember that we find x by doing negative b over 2a. In this case, our b value is a negative 4. So I have a negative 4 over 2 times a, and our a here is 1, which simplifies to a positive 4 divided by 2, which is 2. So that's the x value of my vertex. So my vertex is going to be at 2 something. You're going to take that 2 and you're going to substitute it into your original function. Okay, so we have 2 squared minus 4 times 2 plus 3. And go ahead and put that into your calculator to make sure there's no mistakes there, but your answer should come out to be negative 1. So my vertex is at 2, negative 1, so I'm going to go ahead and graph that right there. Next thing I need to do to finish graphing this would probably be to find the Y-intercept as well as the X-intercepts. So remember, when it's in standard form, your Y-intercept is always going to be the C value. So I can go ahead and graph the Y-intercept there. And for my X-intercepts, I'm going to go ahead and factor this quadratic. So let me clear it up here. So what two numbers multiply to give me 3x squared, but also add up to give me a negative 4x. Okay, so the only way to get a positive product but a negative sum is going to be if they are both negative, which means my factors are x minus 3, x minus 1. And to get those x-intercepts, I'm going to take each of those factors and set it equal to 0. So x minus 3 equals 0. That means x equals positive 3. I can graph that right there. And x minus 1 equals 0, which means x equals positive 1. And I graph right there. I know that my axis of symmetry is going to be along my vertex. So if I really wanted to, I could add one more point by using symmetry right there. And now connect your dots. Okay, so that's how I would graph that quadratic. And then the next part asks me to graph the equation. So this is the equation of a line. It's y equals mx plus b. You always want to start at your y-intercept. In this case, my y-intercept is a negative 1 right there. And my slope, in this case, is a positive 1. So from that y-intercept, I'm going to go up 1 over 1 to the right. And I'm also going to go down 1 over 1 to the left. And go ahead and connect my dots, just sketch that graph. Okay, so this is a system, and what ends up happening is we find our solutions, and we have, in this case, 2 solutions here. Okay, so I would have a solution at 4, 3, and at that one is at 1, 0. Sorry, it's hard to see with all of this going on. So you have 2 solutions here. The line and the parabola are going to intersect at 2 different points. So that is how you would solve this system graphically if you have the opportunity to graph both of them, or if I ask you to graph both of them. But there's also a way to solve for them algebraically. And so when we are given just the functions, no graph is required. We're going to first make sure that both of these are set equal to y first. We want them to both have y equals on one side so that then we can do the following. We are going to set each equation equal to each other. And this is going to allow us to solve for x. Okay, so because they both equal y, that means I can set them equal to each other. Once I do that and I find x, I'm going to use that x and substitute x into either of my original equations. To solve for y. And I want to make sure that I write my solutions. It could be 1 or 2, no more than 2, as a coordinate point, x comma y. Okay, so let's go ahead and do that for this problem. So after I figured or made sure that y is what they both equal, I'm going to set these equations equal to each other. So I have x squared minus 4x plus 3, and I'm going to set that equal to x minus 1. And you want to go ahead and move everything to one side. So I'm just going to move everything to the left because that's where most of the stuff already is. So I'm going to subtract x, and I'm also going to, and I'm going to do this in one step, but you can split it up if you want, add 1. And so what I want to happen here is I want to cancel things from one side and make sure I move it to the other. So in this case, x squared, nothing happened to it. Negative 4x minus x gives me a negative 5x. 3 plus 1 gives me 4. So now that I have everything on one side of the equation, I need to figure out how to solve for x. And now this is a quadratic, and so we are going to need to factor to solve this quadratic. So what two numbers multiply to give you 4x squared, and what two numbers add up to give you a negative 5x? And hopefully you're thinking that in order for them to both add up to be a negative but multiply to be a positive, they're both going to be negative. So I have a negative 4x and a negative 1x. And if I go ahead and add negative 4 and negative 1, I get negative 5. So that's going to work. So I can use the trick where a equals 1. When a equals 1, I know I can just take these factors, and those are going to be my answer. So my factored answer here is x minus 4 and x minus 1. Again, this trick only works when your coefficient for x squared is 1. You can go straight into the answer, the factored form. So from here, we're going to take our factors, set them equal to 0. So x minus 4 equals 0. I add 4 to both sides, and that gives me x equals 4 as my first answer. And then I take x minus 1, set it equal to 0. And I add 1 to both sides, that means x equals 1. Now, this is not your final answer, and if you stop here, you're not going to get full credit. You need to make sure that your answer, your solution, is a coordinate point. So I only have the x values right now. I know it's going to be 4 comma something, and that something I'm going to find out by substituting into either of those equations. And you can choose, I'm going to choose the second one because it seems simpler, okay? So if I substitute in 4 for x here, that gives me 4 minus 1, which is 3. And because it's already y equals, I know that's going to be my y value. So here's my first solution. My second solution is going to come from the x equals 1. So again, it's going to be a coordinate point of 1. This, I'm going to substitute again to either. I'm going to just use the same one. So in this case, I'm doing 1 minus 1, which is 0. And that is my second solution. So thinking about what these solutions mean, these solutions show where these two graphs would intersect. So this is going to have two solutions, it's going to have two intersections, and these are both of the answers. Okay, let's go ahead and try this example. I want to go ahead and pause the video here and have you try it. Follow the same steps and make sure that you get a coordinate point as your final answer. So hopefully you went ahead and tried both of these. So let's go ahead and try them together. So make sure that they're both y equals first before I go on to the next step. So setting these equal to each other. Okay, and then I want to move everything to one side of the equation. So I'm going to just move these to the left by subtracting them, which gives me x squared minus 2x minus 8 equals 0. And I am again here with a quadratic, so you are going to need to factor what two numbers multiply to give me negative 8x squared, and also add up to give me a negative 2x. So I know it's going to be 4 and 2 somehow. And then I need to figure out which one's going to be negative. So I know that probably the bigger number needs to be negative since my answer is going to be negative. So the 4 will be negative there. And remember, there's a trick. If your coefficient for a is 1, you can go on to the answer from there, which will be x minus 4 and x plus 2 as my answers. From here, I'm going to go ahead and take each factor, set it equal to 0. So x minus 4 equals 0. I add 4 to both sides, giving me x equals 4. And this one, x plus 2 equals 0. So I'm going to subtract 2 and get x equals negative 2. Remember that your final answer should be a coordinate point. So this is going to be 4 something, and this is going to be negative 2 something. So in this case, I am going to substitute this 4 into either one. You pick. It can be the top, the bottom. We should get the same answer. So I'm just going to go with the top one this time. 4 squared is going to give me 16. So that's my first answer. Then I have negative 2 in this case. And top or bottom doesn't matter. Just be careful if you choose the quadratic that you are squaring, including that negative, because then my answer here will be a positive 4. And if you forget to do that, in this case, it won't matter, but it could if you had another term after the x squared, okay? So here again, I have 2 solutions. Okay, going on to example 2, these again are being done in the back of your notes that we gave to you. And then we're going to come back to the front, which is where we're going to do some graphing. So again, let's go ahead and pause the video here so you can try to do number 2. Same process with number 2. We're going to take both of them, make sure they're both y equals. I'm going to take 2x squared minus 5x minus 10 and set it equal to the other equation, negative 12x plus 5. I'm going to move everything to one side, so I'm going to move the 12x over by adding it. Just be careful that you're adding it to the x term, and then I'm going to be subtracting the 5 from my number term, making these cancel out. So the 2x squared wasn't affected at all. This is going to become a 7x positive there and a negative 15 here. So now we're going to do some factoring. I know that this one's going to be a little bit more work because my coefficient is not 1. In this case, it's 2. So same process though, I'm going to ask what two numbers multiply to a negative 30x squared and also add up to a 7x. So go through your factors. How do you multiply to a 30 but somehow add up to a 7? Hopefully you're thinking 10 and 3. Okay, and I know that my sum needs to be positive, which means the smaller number is the one that's going to be negative. So in this case, I can't just jump to the answer. My answer is not just going to be x plus 10, x minus 3. Because I have a coefficient in front of the x squared, that means I have to go on to grouping, which is a little bit more work. So what you're going to do instead is you're going to rewrite the middle term, 7x. Instead of writing 7x, you're going to write it with your new terms that you came up with by doing that factoring process. So I'm going to write plus 10x minus 3x minus 15. So you're essentially rewriting this function, just making it longer and replacing that middle number with 2 of them instead. Okay. From here, you're going to factor by grouping. So I'm going to group the first two terms and the last two terms. When I looked at my first two terms, I have a 2 in common. So I'm going to take out a 2, and I also have 1x I can take out, which means inside I only have 1x and then a 5, because 2 times 5 would give me that 10. For my second factor, I'm going to take out a -3. You always want to take out the negative. And inside you're going to have an x, a plus, because you took out a negative, and a plus 5. So you know that you're doing this right if your factors here are the same. That's good. So I have an x plus 5 here. And then whatever you took out, the 2x minus 3, that becomes your other factor. Okay, so this is your answer for the factoring portion. So then what you're going to do, you're going to take these factors, 2x minus 3, set that equal to 0, and take your other factor, x plus 5, and set that equal to 0, and then solve for the x value and substitute it back in. So when I add 3 to both sides, 2x equals 3, then I'm going to divide by 2. I'm going to just leave it as 3/2. You can also say 1.5 if you like decimals better, doesn't matter. This one I'm going to subtract 5, and I get x equals -5. So again, your final answer needs to be a coordinate point. So we're going to take these numbers and we're going to substitute into either. Again, I always go for the easier one. So in this case, I'm going to substitute into the second equation. And just be careful that you are using your calculator here, because you may not like fractions, and we don't want to mess that up, okay? So then here I end up with a -13. So my first point of intersection is 3/2, -13. Again, you can, if you prefer to have a decimal answer, that's totally fine. And then for this one, again, substitute. I'm going to use the same one, the second one, -12 times -5 plus 5. Use your calculator just to be safe, and you get 65. So your final answer is the coordinate point, -5, 65. All right, this last problem, number 3. So for the instructions, since you don't have this on your paper, just say, what are the x coordinates for the following? And here's the system that we have, and this one looks a little bit different, but thankfully it only wants the x coordinates, so I only have to find x. I don't have to go back and substitute it in for y. Okay, but let's look at what is happening here. And so I have 2 equations, and then I have a y in here. So it's not y equals. Now I could set it equal to y. I'd have to move things around, combine like terms. Or I could substitute in the y value, because I also have this over here, and y represents x minus 4. So that's the route I'm going to take in this one. I'm going to have x squared plus 2x plus 3, and instead of writing y, I'm going to write x minus 4. So I'm replacing the y with the value that it's telling me it equals, and then minus 12 equals 0. I want to make sure I have the same variable so that I can work with it, and I know I want to be, I want my answers to be x's, so that's why I'm not solving for the y. So I'm going to go ahead and simplify this. The only thing that's affected by me substituting in the y value is the 3. So the 3 is going to simplify into something else. I have to distribute the 3 through. So this is 3x, and then this is going to become minus 12. Everything else in here should stay the same. So I have a minus 12 here, and I have a 2x and an x squared. Okay, so I'm going to combine like terms here. These can combine, giving me a 5x. And these can combine, giving me a negative 24. And if you want to make sure of that, go ahead and put it onto your calculator. Okay, so this is a quadratic. Again, I only want the x coordinates, so I need to figure out what two numbers multiply to negative 24x squared and also add up to give me a 5x. And hopefully you are thinking 3 times 8 gives me 24. And somehow 3 and 8 can also give me a 5. One of them has to be negative. That's going to be 3. Now, because a here is 1, you can go straight into x minus 3x plus 8. Remember, this only works when a equals 1. And from here, we are going to set each factor equal to 0. So x minus 3 equals 0, which means x equals a positive 3. And x plus 8 equals 0, which means x equals a negative 8. And those are my answers because I only want the x coordinates for this problem. So we're going to do the same thing. Go ahead and we're going to pause here, pause the video, and for this last problem, we're going to set it up very similarly. We're going to take this y and we're going to substitute it with what y equals. So I have 2x squared minus 5x plus 3 times 3x plus 5, then minus 17 equals 0. So again, this is the only thing being affected at first. I'm going to distribute that and get 9x plus 15, but everything else in my equation is still the same. I'm going to go ahead and combine like terms. I can combine these two. So the 2x squared is there, and then I have a plus 4x, and then this can be combined to a minus 2. Now I can go ahead and try to factor this. So are there any two numbers that multiply to give me a negative 4x squared and also add up to give me a positive 4x? So I go through and I try negative 2 and positive 2, but that would give me 0. I could try 4 and 1, but that can't add up to be a 4x. So unfortunately, in this case, factoring is not going to work. So in this case, if factoring doesn't work, then I'm going to go on to my quadratic formula. Now, before you start the quadratic formula, you need to remember what a is. So in this case, a is 2, b is 4, and in this case, c is negative 2. Then you're going to go through and use the quadratic formula with these values to help you get the answer. So my quadratic formula is negative b plus or minus square root of b squared minus 4ac all over 2a. And you want to use your calculator to simplify these just to make sure that you don't get any mistakes. You don't want to mess up here. So if you enter just what's inside the radical, nothing else, don't put the radical in, just what's inside the radical, that should give you a 32. And so again, because I didn't include the radical, then I'm going to just write it as square root of 32. I have a plus or minus here, a negative 4 in the front, and a positive 4 at the bottom. Now, before I can start simplifying this, I need to break down that radical. So break down the radical of 32, see if you can find any pairs. So what multiplies to 32? 2 times 16. You're going to stop at every prime number. 16 is 4 times 4. That's 2 times 2. And that's 2 times 2. So take out any pairs. So I have 2 pairs of 2's. So those 2's are going to come outside. They're going to multiply on the outside. Anything that stayed inside that wasn't paired up with anything, so that single 2 is going to go inside the radical. So this becomes 4 square root of 2. So square root of 34 can be simplified as, square root of 32 can be simplified as 4 square root of 2. So here I'm going to rewrite this as 4 square root of 2 instead of square root of 32. And the reason why I'm doing this is so I can simplify. I can divide everything here outside the radical with the 4 in the denominator. So then I can divide negative 4 divided by 4 gives me a negative 1, plus or minus 4 divided by 4 is a 1 with the square root of 2. So here are 2 answers, and because it's a quadratic, I do have 2 answers. So I have a positive and a minus. You don't have to go through and enter that in your calculator, but if you want to practice that, go ahead and do that, and I'll give you the decimal. So when you do -1 plus the square root of 2, you should get 0.4142, and it keeps going. And then you can also do -1 minus the square root of 2, and that gives you -2.4142, and it keeps going. So that's the decimal answer. This is the exact answer when you just leave it as a radical, so you can stop. All right, the last part of your notes is the graphing, so go ahead and go back to the front side of the notes we handed out to you, and you're going to see this table right there. So a few reminders when we're dealing with solving systems of inequalities. If we have a equal to under the symbol, you're going to have a solid line. And if there's nothing under the symbol, it's going to be a dotted or dashed line, okay? So when we're graphing these, just be careful that you are using either solid or dotted correctly. So here we go with the first example, and you have a graph on your paper. You just have to write down the equations here. So y is greater than or equal to x squared minus 4x minus 5. So first thing you want to do here is find the vertex of this problem. So I'm going to start with my quadratic. I know it's going to be a solid line. Okay, and it's greater than, so I should be shading above. There's going to be shading when you're dealing with inequalities. So to find the vertex, I'm going to find x by doing -b over 2a. In this case, negative, and then b is -4, and a is 1, which gives me +4 over +2. So the x value of my vertex is 2. And then I have this 2 to substitute into my original equation. So 2 squared minus 4 times 2 minus 5. Go ahead and simplify that. I get 4 minus 8 minus 5, which gives me -9. So I have 2, -9 is going to be my vertex. Your y-intercept, remember when it's in standard form, you can just pull it from the c value, so that's at -5. And you can use symmetry there to plot another point. And then the last thing you can also find out from this is going to be your x-intercept, so you can factor what two numbers multiply to give me -5x squared, and what two numbers add up to give me a -4x. Okay, so hopefully you're thinking 5x and 1x somehow. And my sum needs to be a negative, which means the 5 will be negative. And because a is 1, you can jump right into the factoring. So x comes out to be +5 and x comes out to be -1. And those are going to be your x-intercepts. So now you have enough information to where you can graph this and make sure it is a solid line because of the greater than or equal to. I'm going to go on to do my line, and my line is going to be dotted. I start off with my y-intercept of +2, and I have a +1 slope. And I'm just going to sketch that graph here. And I'm not going to fill it in because it's going to be dotted, so I'm just going to leave it like that. I am going to, however, extend so that I am able to do the shading here. So I want to shade above my parabola, so I want to be somewhere in here, but this tells me I want to be below my line. So above my parabola, below my line, I am within right here. So this is where I want my shading to be in order to satisfy both greater than my quadratic but less than my linear function. Okay. So go ahead and try this last one. It's going to need a little bit of remembering how to graph this quadratic instead. So this is going to be in vertex form. So remember, it should be easy to pull the vertex from here. So let's go ahead and pause the video and try this one. So for the quadratic, the vertex is easy to find because we're going to take what's inside the parentheses, but it's the opposite sign, so positive 3, and then exactly what I see on the outside, so a negative 4. That's going to be my vertex, positive 3, negative 4. Then I have my x-intercepts that I need to find. So to find my x-intercepts, I'm going to set the equation equal to 0 and solve for x. So I'm going to add 4 to both sides. That gives me 4 equals 1/2 x minus 3 squared. To get rid of this 1/2, I'm going to multiply the whole thing by 2. That's going to get rid of the denominator. So I get 8 equals x minus 3 squared. Then I'm going to take the square root of both sides to get rid of the squared. When I take the square root, I am going to get square root of 8 here, and then this just becomes x minus 3. So I'm going to add 3 to both sides. So when I take the square root of 8, I need to remember that this is going to be a positive and a negative square root of 8. So really I'm going to have to split this up into 2 problems. I have plus or minus square root of 8 plus 3. So I'm going to need to do the positive and the negative of that. So when I do the positive square root of 8 plus 3, I get 5.82. And when I do the negative square root of 8 plus 3, I get 0.18. So I know these are decimals, they're not pretty, but we're just going to use what we have to estimate where the graph is crossing. So the 0.18 is going to be like right after the 0, like around there. 5.82 is closer to 6, so right there. Okay, and the last thing that we need for this quadratic is going to be the y-intercept to kind of give us a better idea of where it's crossing. So I'm going to substitute in 0 for x and simplify. So you can definitely use your calculator for this part. And my y-intercept in this case is going to be, let's see here, 9 minus 4. So 9 times 1/2 is 4.5, minus 4 is 0.5. So I'm like halfway right there. Okay, so that's all I have to sketch my graph. In this case, it's going to be a dotted line parabola because it's just less than. So do your best and kind of sketch a parabola that's dotted or dashed. So as long as it's obvious that it's not solid. So that is a sketch of your parabola. And lastly, we're going to graph this line. Start up at 3. Have a -1 slope this time. And for this particular graph, it will be solid because of that equal to right there. So I'm going to do my best there and sketch the graph. And now we need to worry about the shading here. So I want to be below the parabola. And I want to be above my line at the same time. So below parabola means like under the U, but at the same time above the line. So there's actually going to be 2 regions here. Here I am both above my line and also below my parabola, but also here. So make sure that you have both regions shaded. Again, it has to satisfy this both under the U, but above the line.